Hey, welcome back for another Virtual IoT webinar. This week we're going to talk about visual programming. I think over the past few months we've actually done a few sessions around visual programming, different approaches though. Today the presentation is going to be from Tim Jagenberg from Reactive. And if you've participated to the OpenIoT Challenge, or if you followed the OpenIoT Challenge for the past few years, I'm sure you've heard about the tool they're building. Even if you've not participated to the challenge, Reactive has been very active in the IoT and the Eclipse IoT community for the past few years. And yeah, today we've invited Tim to tell us all about how they see visual programming and the kind of tool they build to help people build IoT solutions. So if you guys have questions, please make sure to ask them either on YouTube. I think these days that's actually the easiest way for you to to chat among one another and ask questions as well. You can also tweet at us, Virtual IoT hashtag on Twitter. We'll be monitoring that. And yeah, just make sure that if you have questions, you don't wait and ask them so as we can ask them to Tim as they come. So without further ado, Tim, I will let you move over to your presentation. Maybe you can also briefly introduce yourself.
Well, thanks a lot for the introduction, Benjamin. I'm Tim Jagenberg. I'm responsible for the technology side here at Reactive. Let's switch over to my presentation. There we go. Yes, as I said, I'm the tech lead here at Reactive. We're an IoT company from Trondheim in Norway. On the left side, you can see the Technobyen, the technology city in Trondheim, which is where our offices are located. Trondheim is the technology capital of Norway. It's located quite in the center of Norway, directly at the Trondheimsfjord, quite nicely. And it's home to two of the very big technology and science organizations in Norway. First, that's the NTNU, the Technical National University. And on the other side, it's SINTEF, the largest research organization in Scandinavia. And aside those two, we also have a couple of leading tech companies here. I guess a lot of you will be familiar with the Arduino. The brain of the Arduino, the AVR chip, is originally a development by two NTNU students through Atmel. So that's a product here from Trondheim. Similarly, if you're using a mobile phone with an ARM Mali graphics processor, that is also developed in Trondheim. And also the Bluetooth chipset in many mobile devices will be from Nordic, here also from Trondheim as well. So as you can see, we're maybe not as known, but we're quite a busy technology city. Towards Reactive, we have two sides. We originate on the right side from the tooling. Reactive Blocks is a visual tool for application development. It originated as a PhD thesis at the National Technical University by our inventor Frank Kremer. And during the development of this tool, we accumulated a lot of knowledge around demonstrations, proof of concepts. And then we started to apply this experience towards solutions. So now we're also building IoT solutions, mostly focused around the gateway, and apply our knowledge in this context. But first, a few words about our tool, Reactive Blocks. We all know this. You end up with quite a bit of chaos on your desktop, and then you use a couple of boxes to organize everything neatly. And that's basically the same thing we do with Reactive Blocks. Reactive Blocks is a couple of plugins for the Eclipse IDE. And Reactive Blocks enables you to graphically develop your applications based on building blocks. As you can see here, you define your application based on UML activity diagrams. That application is then generated into source code. The source code is compiled and packaged and can then be deployed to a gateway like the hierarchical gateway we see here on the right-hand side. Reactive Blocks works hierarchically. So each block can again contain blocks and other operations, which again can contain blocks and operations. So you can hierarchically structure your application, which makes it a lot easier to reuse components and share work with others in your team or company. Each of these building blocks is defined with a contract. The contract defines which states a block can be in and how we can interact with that block, which pins can be used in which state, in which order. So we have a very clear definition of what we can do with a block. Based on these contracts, you can visualize the whole state of the system, the whole state environment. Transitions between individual states, events which can occur in each state. And this makes it very intuitive to understand complex systems and debug them. Also based on the contracts, we can apply a stateful analysis. We can look at the system and determine if certain blocks are used in a way which they are not meant to be. In this case, we're using the robust MQTT block. We started with the init parameters, and then immediately when it's ready, we terminate the application with this termination pin without stopping the block first. And then once we run the analysis, we get a complaint that the block is not terminated correctly. So simple errors in a system like this are automatically caught by the stateful analysis. And together with the tool, you get an extensive library of ready-to-use building blocks. We've covered various areas related to the Internet of Things, different communication protocols, different low-level protocols to interact with I2C sensors or just simple GPIO pins, as I will show later. But you can, of course, extend that library with your own blocks as well and share blocks within your team or organization. Towards the solutions we build based on reactive blocks. The obvious first demonstration we did is, of course, the Internet of Plants. We developed an automated greenhouse for a chili plant. We were using the chirp sensor, which can monitor the humidity in the ground. We used a little pump and a cloud for monitoring, a camera for live video feedback, and a grow light to automate everything. And we're quite effectively growing chilies in our office with that. The currently most active project is in the e-health context. Here we are cooperating with two local communes, the commune of Trondheim itself and a combination of smaller communes in the Værnes region nearby, to develop a solution which supports elderly or cognitive disabled people. The idea is to enable them to live at home longer and also to increase their living quality when living at home or in a care home. The whole solution is governed by the Continua framework, which is briefly highlighted on the lower right side. The Continua framework is the established e-health framework for Scandinavia, which defines the IT architecture and the communication protocols and standards which can be used in the e-health context. Based on this framework and the interaction with our users from the communes, we identified a couple of use cases and developed the first prototype, Baldwagt, which you can see at the bottom, which we actually deployed in test homes and also in support homes where people are supported by communal workers. The initial use case we focused on is a simple night guard. It's monitoring activity in front of the door, inside in front of the door, and the door itself. And if somebody approaches the door in the middle of the night, it gives an audio warning that it's in the middle of the night and it might be a good idea to stay in bed. If the person then continues and opens the door and leaves the building, the person responsible for this user will be sent an SMS, so they can take action and maybe drop by, have a look what's going on. Another use case which we identified is the monitoring of the sleep. Usually the health workers are visiting a couple times of night to see if everything is in order. But if they would know that the person has continuously been sleeping and did not leave the sleeping room, that would simplify the process a lot and would reduce the nightly visits, which would also increase the living quality of the user in that home. With the solutions, I will directly jump into the demo. The demo is based on Eclipse technology. We're using Kura as a software stock on the Raspberry Pi 3 gateway. And we use Reactive Blocks from Reactive to develop the application. The goal of this demo application is to use the Kura configuration interface to toggle these 3 LEDs, which you can see on the breadboard. So I will jump over to my workspace. This is Eclipse with Reactive Blocks installed. There are 2 ways you can get Reactive Blocks. Either you download the ready-made product from our website, or you can install the plugins in an existing Eclipse installation through the marketplace or through the normal update sites. So there are various ways leading to Reactive Blocks. The first thing we need to do when we work for a Kura project, we need to make the workspace ready for Kura development, which means we need to import the Kura target platform specification, which I will do right away. First, I need to go over to the Package Explorer, import an existing project into my workspace. I'll do that directly from the archive file, which I downloaded from the Kura homepage. Here is a user workspace archive for the correct version, which I'm running on the Raspberry Pi. And then I import all these projects. The same process we need to repeat with the target platform for Reactive Blocks based on Kura, which builds on top of the Kura target platform. Again, we import the project. And then we need to open the target platform. We can see that the Reactive Blocks target platform is actually referencing the target definition of Kura itself. And then we can set this Reactive Blocks Kura target platform for our workspace. You could see all the projects here turned, well, not green, but yellow at least. And then we can switch over to blocks and start building our application. We create a new Reactive Blocks project, give it a name. And then we need to choose plugin project for OSGI because Kura is an OSGI platform. Once we have our project, we create a new block. Again, we give it a name. Kura config LEDs. LEDs controlled by the Kura configuration. And then we need to tell the system that we want to build a Kura application with configuration. We get an empty building area, only populated by the start pin. This is where our application starts in the very beginning. And then we can start to populate our thing. We want to react to the Kura configuration. So from the Libraries Explorer in the Block Explorer, we can choose the Kura config listener, drag it into application. Then we can clean it up a little bit to suit our needs. You can rotate these pins around the block by simply pressing the R button. And you can move them up and down by pressing the up and down or left and right cursor buttons. So we have the config listener. And then, of course, we need blocks to control the LEDs. Here's a little quirk. The Kura config listener is part of the Reactive Blocks target platform, so we don't need to worry about that. We can just use it. But the LED block, which I just built for this project, is not part of the target platform. So we need to copy this one into our project by right-clicking it and duplicating it. And then we choose the project we're working on, copy that block into our project. You can see it's now in our project. And now we can use the block by simply dragging it, similar to the other one from the library. Clean up a little bit again. Make the block a little bit more compact so we have enough space. And then we need 3 of those blocks. As you've seen on the slide, maybe I have 3 LEDs, one in green, one in yellow, one in red. I can use copy and paste to simply duplicate this block a couple of times. We'll arrange it nicely. Okay. And then we can parameterize these blocks. This block, compared to the other config listener, has a little P in the upper left corner, which means there are parameters to be configured. So if I right-click and select the parameters, we can now configure the GPIO pin, which is connected to this LED. So this one is pin 3. This one would be pin 5. And the last LED is pin 7. Now we have all the essentials for the application in our environment. Now we need to wire it together. You can see we need to start the config listener. We need to start the LEDs. So we do that together at the same time. In order to branch out, I will create a fork here. Similar to the pins, you can use R to rotate the fork depending on your layout needs. And then I start to wire the application together. I go to the fork, I go to the start of the config listener and of the LED. And then with the LEDs, it helps to understand how they behave. So let's have a look at the contract. I open the contract for the LED, and I can see that I have an initial state. And here there's a circle with a slight border around the final state. And from the initial state, I can get into the active state by the combination start, which will react and start OK. And then I'm in the active state. It could also happen that I interact with start and I get a start error if something goes wrong in the initialization. But we assume everything works. So we will get a direct feedback start and then start OK. This we can use to chain the starting of these LEDs together. So I continue wiring stuff and I use the start OK of the first LED to trigger the starting of the next LED. And the same with the second and the third. And this way they chain together and start each other. Just a little bit of cleaning up here. Then we have the config listener. It's a block which hooks into the Kura system. And anytime somebody changes the configuration in Kura, this configuration update will be coming out of updated config or the initial config out of here. Both are a map which is linking a string ID to an object with a value you set in the configuration. The next step is we first need to define this configuration. Reactive Blocks already opened this XML file for us, which is the service definition for Kura. It contains an icon which is used by Kura to visualize the component. And then we have a couple of properties here of configuration options. Each of those options has an ID, name, type, default values, and so on. To cut it a little bit short, I will just use the prepared configuration and paste it into the one in our project. You can see I set the icon to our Reactive icon, and we have 3 configuration options, which all have an ID assigned to them. The Kura LEDs are for the red, Y for yellow, and G for green. Each of them is a choice of on and off. So now that we have this defined, we can go back to our application. We know there will be updates to the configuration coming out of this block. And in this case, we don't really care if it's the very first initial configuration or an updated configuration. So we use a merge block to merge these 2 signals into one. We don't really care which one we get. And then we need to use that information in this configuration map to update the state of each LED. So we need to spread out again by using a fork, again using the orientation differently, and wiring it up. Each of these LEDs expects a Boolean, which defines if it's on or off. And as we can also see here in the analysis window, it does not match. The information we get from the config listener is a map from string to object, but we expect Boolean as an input here. So what we need to do is we need to define an operation which converts the configuration map into the correct Boolean for this LED. What we can do is we can add elements into an existing flow. And in this case, I will add a new operation. Give it a meaningful name. In this case, get red LED. So we get the status of the red LED. And then I can start to customize this operation by simply double-clicking it, which opens the standard Eclipse Java editor. So first we need to modify it a little bit. We need a Boolean as a return value. And we know that we get a map from string to object as an input for the preferences. It complains because we haven't imported the util map yet. Now it complains because we don't return anything, so we need to get the right thing from the preferences. Now I need to know which configuration option I need to get. Then I can look back into my service definition and I see, okay, for the red LED, we need this ID. I copy it, paste it over here in my get from the map. Send the whole thing to a variable, which in this case is a string. It's not a typed map. Well, it's typed, but it's typed to object, so we need to map it to a string. And then we can react on the content of the string. We check if the string is on. If it's on, we get a Boolean true. If it's not on, we get a Boolean false. So repeating this for every LED again, I jump to my little notepad and copy and paste those methods in. So we have 3 methods: get red LED, get yellow LED, get green LED, each mapping the preferences map to a Boolean for the respective LED. Reactive Blocks updated the operation already with the new input and output pins. And now we can also use the other methods we defined in our flows and add them in here too. The one for the yellow LED and also the one for the green LED. So that looks pretty good. One thing we need to do if we want to write a proper OSGI application, we also need to terminate the application. So we have a look in our library again, and then in the OSGI section, let's get the termination. A bit of cleaning up again. We extend this one a bit further down, wire it up. And then we add the activity final node, which means the application is stopped. Wire it up to the termination. And then we think everything is good. So let's run the analysis. And it's complaining. It's exactly what I was pointing at before with the contracts. The LEDs are now all in the active state after we started them. And we're simply straight away terminating the application, which harms the contract of the LEDs, which we get as a warning here. So instead of terminating directly, we terminate the first LED and then chain them together again, similar to the starting behavior. Once the first one is stopped, we get a result out of stopped. We stop the next one, stopped, stop. And when the last one is stopped, we actually stop the application. Now everybody should be happy. No complaints in the analysis. And now we can actually build the application. Now we can convert our code into Java source code. This works through the right-click build menu. We rebuild the whole project as an OSGI bundle for Eclipse Kura. I need to save, of course. It analyzes the code and builds the source code. Here we can see the generated source code for our project. And it also creates a deployment definition file for us, which contains the information which bundles are needed. This one we can just compile into a deployment package using the mtoolkit quick build. We got a deployment package. And now it'll be interesting. Let's see. I'll briefly need to stop sharing to reconfigure my video camera. Okay, we're back. I'll give you the video in an extra screen. Here we have our little demo Raspberry Pi, which is running Kura, is connected to a local network. And I will head over to the Kura admin interface. Go to the packages, install the package we just created. Here is the deployment package. I upload it. It appears here in the package list, and over here in the services definition, the interface appears as well. And when I click it, we can see the interface we defined before in the XML file. We have 3 options for the LEDs, each with the possibility of turning it on and off. Let's see if I need to exit the full screen to keep it above. Okay, now we can see both at the same time. I switch the red LED to on. I apply the configuration change. And it works. The red LED turns on. Let's try the other 2, turning the red LED off again. And there we get configuration interaction with the GPIO of the Raspberry Pi. I built a similar application based on MQTT, which I will briefly demo. Let me first turn everything off. I remove the package we don't need anymore. Head back to Reactive Blocks. And I will just import the other MQTT-based application, which I prepared already. I forgot to switch to the directory mode. I was still looking for archives. And then I import the, check the right version, the MQTT LEDs. Now we have an additional project here, MQTT LEDs. It works very similarly. Again, we have the starting point. We start, in this case, the cloud client handler, which attaches to the cloud client of Kura and is interacting with the messaging system, which is based on MQTT. We again have the termination, which in this case first terminates the cloud client handler and then stops all the LEDs. The starting is also handled, well, in this case, it's actually handled in parallel. We start here, and then all LEDs are started at the same time. This tool, which is highlighted here, is another option to simplify a diagram. If your application becomes too complex and too many wires are going across, you can use these navigation pins to jump from one point to the other. Once a message arrives in Kura, we receive a Kura message out of this pin. We then analyze this message for the intended status. If the LED is supposed to be switched on or off, we buffer that status in a Boolean. Then we analyze the message for which LED is meant. Just generates an integer output, and based on this integer output, we make a decision, get the buffer back, and set the LED to the buffered value. Simple function. I will briefly demonstrate that. I go to the Kura interface again. I will install the prepared deployment package.
And just maybe, sorry to interrupt, just a quick reminder for everyone watching. If you have questions, you can feel very free to ask them on the YouTube comment section, or you can also tweet using the Virtual IoT hashtag.
Exactly. Yes, so I just installed the MQTT-based LED application. It is running in Kura. We get the interface here in services. And then I will switch over to my phone, which is connected to the same MQTT broker as Kura. Let's see. You can see the toggles in the MQTT interface. And by toggling in the MQTT interface application, I can send an MQTT message via our broker to Kura, which then ends up in the Reactive Blocks application and controls the LEDs. With this demonstration, I'm basically through. Let me just switch back to the correct camera. Okay, that was it from my side. If there are any questions, I'm happy to take your questions now. Otherwise, I'm going to say thank you, Benjamin, for inviting us, and it was a pleasure.
Well, first of all, thank you for the great demo. You had quite a setup, actually, so that was really good. So yeah, I don't know, like, yeah, we will probably have a few questions in the next minutes, I would hope. And at least I have one. How about other programming languages, like for IoT? Some people might want to use maybe C or C++, or at least use some native libraries from their Java code. So is there anything that Reactive Blocks can do to help for people interested in other programming languages?
Other languages, not directly. In principle, the code generation is not language dependent. We had a prototype in the early stages which could generate the C++ code. But the current version of Reactive Blocks focuses only on Java, but it does generate just plain Java code. So anything you can do in Java, you can do in Reactive Blocks as well, which means you have full access to the Java native interface. You can integrate with libraries which are written in other languages. That is all possible.
Okay. Maybe, I mean, hopefully, this is just not me. We didn't pay attention, but can you maybe elaborate a bit more on how should people can and could use Reactive Blocks? Where do they download it? How what's maybe the licensing model? Is this a free tool, or what's? Yeah, can you elaborate on that?
Good you ask. First of all, you get it on our homepage, www.bitreactive.com. There you can download the complete product where you get Eclipse with Reactive Blocks already pre-installed. That's the easiest way to get started. Reactive Blocks is a freemium model. You can download Reactive Blocks for free. The only limitation you have is the blocks you build yourself, you need to publish. If you're using the free version and you build your own blocks, those blocks will be published under the Eclipse public license and are free to use for everybody else. Only if you buy the commercial version of Reactive Blocks, you can use private blocks which are not published. It's in a sense similar to the GitHub model where your free repositories are visible to everybody.
Yep, that makes sense. Okay. And maybe to push that a bit further, can people, if people are interested in actually kind of monetizing their blocks, are you providing a business model around that? If I have like this super fancy security algorithm that I'm going to bundle in the form of a block, can I sell it, or can I maybe share the revenue with you guys, or what's the model there?
That's the idea, exactly, that we create a market around these blocks, which are visible on blocks.bitreactive.com. The current payment system does not support it, but that's precisely the idea. If people create their own blocks, they can share them via the blocks interface, and depending on the licensing they choose for their blocks, that could also contain commercial interests.
Okay. Okay. Well, for some reason today people are very shy. We had like lots of people compared to what we get usually, but no one is asking questions. But turns out I have many questions. Besides Eclipse Kura, and it doesn't need to be Eclipse project, are you looking at integrating reactive blocks with other popular IoT technologies / frameworks? I mean, you mentioned Kura, you mentioned MQTT. Anything else on your radar?
I mean, our basis is Java. Anything which can run a Java virtual machine can run reactive blocks.
Mm-hmm.
Of course, there are other OSGI frameworks around which we also integrate with. One maybe to name would be the MBS from Bosch. But in general, we are very platform agnostic. As I said, reactive blocks creates standard Java code, and that works on any Java platform.
Okay, good. So I think we ran out of questions, at least the ones I had. But very briefly, and that will give people a few more minutes to ask questions if they have any. I think we will be back in almost a month, actually, on April the 5th, for a presentation about the Samsung Arctic board. I don't know, Tim, if it's something that you've played with. It's actually a nice...
Actually very interesting for us.
Is it?
Recently looking into that platform.
So it's, yeah, I really like it as well. And Samsung is really doing a lot of progress around providing modules and development kits for IoT.
Yeah, I think the development IDE is based on Eclipse J, isn't it?
It is, and so that's exactly what the presentation is going to be. Beginning of April, we'll have Dan and Brad, respectively, from Samsung and from CodeNV, the company behind Eclipse J, and they will basically tell you how you can use your IDE to develop for Arctic, and they really integrate lots of stuff for building for IoT, including remote debugging, etc. So I'm really looking forward to that one. I think many of you guys are as well. I think we already have lots of people who RSVP'd. And and why are we going to be back only in a month? Because in 2 weeks' time, it's actually going to be the Eclipse IoT Day in San Jose, in California. And many of us from Eclipse will be there. And the IoT Day will be the opportunity for you guys to learn more in person about what's going on at Eclipse, all the way from what's being built from for cloud solutions, what's available in open source for securing IoT solution, etc., etc. And the website is there, right? If you go to Eclipse IoT website, you'll find the event. And we have a special discount code for you guys. So if you use the IoT Meet 20, it's 20 as in 20% off of the registration price. So I'm looking forward to seeing many of you guys in San Jose. It's only in 2 weeks. So if you plan on attending, actually, please ping me and ping Roxanne as well. We'd be happy to meet you guys and maybe share a few drinks, right? So that's the IoT Day, and I think that's a wrap for today, right? We didn't seem to have any more questions, but of course this was recorded. So if you have, if you're watching the recording and if you have questions for Tim, please just comment on the YouTube video or on the meetup event page, and we'll make sure to forward those questions to Tim. Tim, thanks very much. That was really a great presentation, a great end-to-end demo. And yeah, take care, everyone, and we'll see you next time.
See you next
Bye.
time.